Hello everyone and welcome to Physimania. In today's topic we will be learning about units and conversion of units. So before we start I want to let you know that in the box description you will have the time and the sections that will be covered in today's video. So if you want to skip to a specific section you can just look at the time and go to that specific section. So without further ado, let's just start. So the first thing I want to let you know guys is the motivation to use units in science. So sciences require experiments to test natural phenomena. For example, a natural phenomena could be simply the mere fact of throwing a ball up in the air and measuring the acceleration of the ball in its trajectory. So if you realize the key word here is measuring. Measuring is the purpose of physics experiments and all science experiments. So because what we want to do is measure a physical phenomena, a natural phenomena that is occurring. Units is basically what tells us what we are measuring. For example, in the case of a ball falling down to earth, the acceleration is measured in terms of meters per second squares. These meters per second squares is basically what it's telling us, what we're measuring. It's telling us we are measuring the acceleration, and the number in front of it, this number right here, is simply indicating the value of this acceleration. But the key to understand what we're measuring is always the units. So when we measure a physical quantity, we do this by comparing the physical quantity we want to measure to some other reference standard physical quantity. Now, I know this may not make sense right now, but let's illustrate this with a simple example. So what I want you to imagine is that we have this car and we have this beautiful house right here, and we wanted to measure the length from one end of the house to the other end of the house. We could do this in many ways, but one way that could be very simple is to get this car as a reference object, as a physical standard quantity, and put it in front of the house and see how many times the car fits from one end of the house to the other end of the house. In this case, our house is 2 cars long, and for example, we could do this in many other ways. We could get a bicycle and say our house is maybe three bicycles long. But in this case, our reference object is a car, and the object that we want to measure is our house. So we say that the length of our house is equal to 2 cars. So in this specific example, what we see is that our house, right, from one end to the other is 2 cars long, right? So the length of our house is equal to 2 cars, right? And you have to be careful, right? Because now the length that we're measuring is in terms of cars. Our units are cars. Thankfully, scientists are clever enough to measure lengths and other units. They came up with other standard reference, for example, such as the meter or the feet or the inch, or in case of the temperature, we can measure in degrees Celsius, in Kelvin, in Fahrenheit, and many others. But the main point that I want you to take from this right now is that in order to measure an object or time or the weight of a person, what we need is first to have some physical reference that we use, that is what we call in science the units. In this case, for example, we use cars, but we could have using very well just a meter stick and measure, for example, and say this is like 4 meters long. Therefore, the length of our house with this meter stick is 4 meters. So this brings me to my next point, is that history has shown that humans have the ability to do the same thing in many different ways. For example, we measure length in meters. We could measure it with cars, as in the example above. We could measure it in inches, in feet. So what we need is a system that allows us to convert from one unit to the other. In this case, for example, in the example above, right, it will be a conversion that would allow us to convert from meters to cars, if this was what we are interested in. So let's take a simple example and explore this conversion of units. So in the case of miles and kilometers, for the conversion of units, what we have is that 1 mile is equal to 1.6 kilometers. So what we mean here is not that 1 is equal to 1.6. That's not what we mean. That's not what we mean at all. This is wrong. This is not what we mean. What we mean is that 1 mile represents 1.6 kilometers, right? So what this means is that if we take a ratio of 1 mile, or to make it short, 1 mi divided by 1.6 kilometers, this is equal to 1, because they are equal to each other in the sense of units, not in the number specifically. What we mean here is that they represent the same amount of length. That's what we mean. So with this fact, what we are doing here is that we are creating a conversion. We're creating a ratio that will allow us to convert from one unit to the other. So let's jump into an example. Okay. Before we jump into the next example, I want to emphasize that if we had 1.6 kilometers over 1 mile, this will still be 1, because at the end, remember that both of them are equivalent in length, in the length that we're measuring, and this is equal to 1. Okay, so the example that I want you to consider is that we have person A and person B standing next to each other. Now, person A measures lengths in kilometers. Now, person B measures lengths in miles. Okay, so my question is the following: if person A measures the distance from house 1 to house 2, and he measures the distance to be the length equals to 3.2 kilometers. So what is the distance? What is the distance that person B measures in miles? Okay, so if we look back to our conversion of units here, we have that 1 mile is equal to 1.6 kilometers, and we have this ratio that is equal to 1 that we can use to transform from 3.2 kilometers into miles. Hence, what we can do is we can write 3.2 kilometers is equal to 3.2 kilometers times one of these ratios. Now, which one is the correct one? So remember that we want to cancel the units. So the right conversion, the right ratio should be this one, because we have that in our expression here, kilometer is on top, and here kilometer is on the bottom. So what this will do is it will allow to cancel the unwanted units, which in this case are kilometers, and get the wanted units, which are miles. So writing that ratio, we get 1 mile divided by 1.6 kilometers, and what we can see is that the units cancel, as said before, and then we get 3.2 times 1 divided by 1.6, which is just 2 miles. And we see that person B measures that 3.2 kilometers is equal to 2 miles. Okay, so now let's look at another example. Okay, so person A measures the velocity of a car to be 300 kilometers per hour. Now, what velocity does person B measures in meters per second? Now, from before, right, we know that 1.6 kilometers equals 1 mile, right? So again, we can start by doing 300 kilometers per hour can be written as 300 kilometers divided by 1 hour times the ratio of converting between kilometers to miles, which is 1 mile divided by 1.6 kilometers. And what we see again is that kilometers cancel, we get the first units that we want, which is miles, divided by hours. So this is 300 times 1 divided by 1.6. A quick calculation in your calculator will give us 187.5 miles per hour. Now, if we look back at what the problem is asking us, it's saying what velocity does we measure in miles per second. So this means that our denominator is wrong. We have to change from hours to seconds, right? So we're missing a conversion here. What is the conversion here? We know that 1 hour is equal to 60 minutes, and 1 minute is equal to 60 seconds. Or I'm just gonna write it S for short. Now we can write 187.5 miles per hour equals to 187.5 miles per hour, and now we need to multiply by our conversion factor or our ratio. In this case, what you can realize is that we need two ratios, right? Because the conversions that we have is 1 hour is equal to 60 minutes, and then 1 minute is equal to 60 seconds. Now remember that if we want the denominator, what we need to put is in the numerator we need to put 1 hour, and then in the bottom, in the denominator, it will be 60 minutes. So the first ratio will be 1 hour divided by 60 minutes, and then our second ratio, what we want to cancel now is the minutes, because we want to convert to seconds. So minutes will go in the numerator and seconds will go in the denominator. And what we have is, as you can see, is that hours cancel out, minutes cancel out, and then if we look at only the units, we will get the desired units, which is miles divided by seconds. Now, doing this in the calculator again is just 187.5 divided by multiplied by 1 over 60 and multiplied by 1 over 60. And doing this in the calculator fast will give you 0.052 miles per second. Now, on a final note, I want to let you know that when we are using units to measure a quantity, These units can only be used to represent the quantity we are measuring. We cannot try to measure time with degrees Celsius or measure length with degree Fahrenheit. And also, I want to let you know that all around the world, the most commonly used units by scientists and engineers are called International System Units or SI units. And I will be leaving you a link in the box of the description with a list of all the SI units and the definitions, which I retrieved from the University Physics 12th edition book. So with this, we're done for the video of today. Hope you like it. Let me know in the comments if you have any questions. Thank you.